Okay. All right. So if you can go to page 180, you can see exponential growth. But uh, before that, we want to see try it now one. We'll come back to it. So try it now one is okay. Okay, it's on page 177, and let's solve it quickly before I go to exponential growth. I'll start sharing my iPad now because I want to write stuffs. Okay, now right now says the number of stay-at-home fathers in Canada has been growing steadily. While the trend is not perfectly linear, it's fairly linear. Okay, that means, okay, so what do you understand by fairly linear? We have actually seen one example of that. A linear equation, the graphical representation of a linear equation is a straight line. I think I've shown this the last time we have met. The linear equation looks like this. It's a straight line, but if it's not quite linear, then it might, the points might go like this, where it's almost linear, but not quite. We have seen, I guess it was example 2, where you could see the line goes, I mean, you could draw, actually goes through different points, which is not exactly straight. So we could say that's fairly linear, but not quite. Okay, so this one will have a similar graph, but definitely we don't need to graph it. So use the data from 1996 to 2010 to find an explicit formula for the number of stay-at-home, and further, then use it to predict the number for 2020. Okay, now we are given a couple of years informations, and from that we want to calculate the explicit form. And if you remember, the explicit form, which is this, the reason I'm writing it this way is to show resemblance with the y equals mx plus b equation. But you don't need to write it in this way. You can write the way the book have written. No problems with that. It's just rearranging equation, so no worries. All right, so we have information from 1976 to 2010. Okay, and how many years in between these two? So 10 from here, and I guess 24 from here. So overall 34 years. Okay, and for D, we know that we need the change in output over the change in input. So if we consider the entire duration, so the change in input would be 34, and now we want the change in output. So change in output would be the population in 2010 minus the population in 1976. So population in 2010 was 53,555 minus in 1976 it was 2610. Okay. All right. So if I use my calculator, I'd get 53,555 minus 2610. So it would be 32,945 over 34. So the final output would be 968.971. Let's take up to 3 decimals. Okay, so since it's the population, it can't be a fraction, can it? Just use your intuition. It's we are talking about people, right? So it can't be a fraction. You can't say that we have 10 and a half men at my apartment, right? We either have 10 or 11. So it can't be a fraction. So as you can see, it's more than half. So we'll say it's 969, right? We're just trying to round it to the next whole number, or the closest, I should say. I shouldn't say the next. It should be the closest whole number. Okay. All right. So we already have D. So this will be our D. Now we need P naught. Okay. Now what's our P naught? Anyone? I've done the hard work for you. Finding D could be the most difficult part, if any. So what would be P naught?
20,610.
Exactly. If you remember, P naught is the given information or value at the start of our whatever time duration we have. So in 1996, it's 2610, right? Oops, sorry. So this would be our P naught. And now this explicit form would have a form like this, would have an outlook like this rather. So it would be n times d, which is 1969, I believe, plus p naught, which is 2610. Oh no, I'm doing it again. 2610. Okay, so this should be one of the answers we're looking for. And now, if we just plug in n, whatever it is, for 2020, we'll get our result. So for 2020, up to, or rather starting from 76, it looks like 44, right? So if we plug in 44 here in place of this n, we'll get our result. So this would be P of 44, which is 969 times 44 plus the initial one, which is P naught. If you add this, you will get your result. Any question from this? Anyone who, I could see a couple of you are struggling um, because I checked my email and the inbox of Canvas. So a couple of you said, I'm confused. You just eventually wrote the formula and not the entire solution. So I hope this makes your life easier. Okay, any question from this? You could see if you know how to play with these informations, these maths are really, really easy. But the only condition would be to know how to play with this, what to do with these informations, what informations can you derive from it, these are the most important. This, if any, this could be the most crucial part. All right. So if you have any question, you can write it in the chat section, or you could unmute yourself, because when I'm writing, uh, I might miss your chat. The information could pop up and go out. Um, so if you see that I'm not responding, you can unmute yourself. Okay, that's perfectly all right. Okay. Um, so now at page 180, if you could open your book in front of you, page 180, you'll see the definition of exponential growth. So previously I've seen linear growth. Again, I'm going to redraw the graph of it. So a linear growth, or the graph of linear growth looks like this, where it's a straight line, and this point where the graph intersects y-axis is b. So this is the length of b starting from 0, 0. Sorry for that. Okay. So this is called a linear equation. This is a straight line, and if the given information gives you this sort of graph, then you can say that it's a linear growth. Even you can eyeball from the given information. The difference from one year to another should be equal. There shouldn't be any discrepancies. But what if it doesn't look like this? What if it actually grows more and more? What if it looks like this? Let's say that means now it actually grows more uh, as it progresses. That means as the time progresses, the value will actually grow more and more rapidly. Okay, so it's not really increasing linearly like the previous one, like this one. It doesn't look like this. It doesn't increase linearly. So that's what the exponential growth looks like. And if you are ever wondering why we are calling this exponential, so that's the reason is y equals e to the x. That's the exponential function. So this actually looks like if I'm not wrong, okay, so e to the x, right? So e to the x should look like this, something like this. You can Google it if you want. Once you finish, you can cross-check whether the graph actually looks like this or not. Okay. Okay. Now, what can we do? Um, what informations can we derive from it? Okay. So if you have seen the definition and the formation of exponential growth, the recursive form looks like this: 1 plus r t to the n minus 1, and the explicit format looks like this: plus r to the n p. Okay, now we want to know what these notations mean. So we already know this is the value we are looking for at the nth uh, time, which is generally in year, but it could be in months as well. We need to take care of that. So this is for the time duration. It's the value in the previous time duration, okay, up to the previous time duration. So if we're looking for a population after 20 years, this will be the population after 19 years, right? Does it make sense? It's just the population the year before or the month before, whatever it is. So same goes for P naught as well, which is the starting value, okay? Whatever the value, whether it's population, whether it's any sort of consumption or so, it's the starting value. And N, of course, um, the time duration, which we are looking for. Now, what does R mean? I guess I should remove this. This might be ambiguous. Okay. So R is the most important part. It is the growth rate. Okay. So this basically means how rapidly it grows or it declines. It could decline as well if it's negative anyway. So this rate will give you an idea whether it's growing or declining, and of course, how rapidly it's actually reaching to its conclusion. Okay, so this rate is the main part of the exponential growth. And as I said, it's a rate. So often it will be given in percentage, and you need to find the decimal of it. So R is basically the decimal format. Okay. Now, let's see one example, and hopefully things will look better. Okay. So let's see example 5. Yeah. And see if we can understand anything out of it. Okay. So example 5 says between 2007 and 2008, Olympia, WA, I guess, what does WA stand for? Is it Washington? Anyway, whatever it is, um, grew almost 3% to a population of 245,000 people. If this growth rate was to continue, what would the population of Olympia be in 2014? Okay. Now, as you can see, the percentage is given. So this is my R, and we need to find the decimal, as I said. So this would be 0.03. So this will be our R, okay? And the initial population is given, which is P naught, which is 245,000. So I'm instead using K for it. You can write 1,000 if you want. And then it wants us to find what would be the population in 2014. Okay. All right, so the first thing we want to calculate, or rather generalize, is the explicit format. So we are looking for this 1 plus R to the N times P naught, right? Yeah. So R is 0.03, 1 plus R would be plus 3, and obviously N would be N. We're not really trying to find any value, so we keep it N, and P naught is 245K. So let's write it in 1,000 now, because we are modeling this. Okay, so this is the explicit format. So that's pretty easy to do, as you can see. If you just find the decimal of your given growth rate, you're there, because it's already given You don't need to find it from any graph or a table. So we have already found the explicit format. Next, we want to find what it looked like in 2014. Okay, so we started um, in 28 because um, the population, the initial population we're talking about is in between 27 and rather 2007 and 2008. So it's the population in 2008 technically. So we'll start from there. So in 2014, it will be 6 years, right? So n equals 6. So we're looking for P6, 1.03 to the 6 and 245,000. If we can calculate this, this will give us our result. So if you have your calculator, you will definitely need your calculator for this type of problems, and you are allowed to do. So you just need to add 1 plus 0.03, which is 1.03. Then you need to have the exponent 6, the power 6 for this. And in the calculator, if you haven't done this before, let me show it in my calculator. Not sure whether you will be able to see or not. Okay, can you see my calculator, everyone? Okay, so you can clearly add these two like this, right? To get 1.03. The next thing you need to use is, I hope you can see my screen or the calculator, is if you have a sign like this, which gives you the power or the exponent. It's for the power. So if you plug in that, it will look like this. You'll have a sign like this, okay? And then we want 6, so we'll plug in 6 and we'll get our answer like this. So if you can't do that, just let me know. It's really, really easy. It's actually given in your book as well. And if you see the calculator, whichever calculator you have, you should have a button like this, where you can use the power for any value, and any, I guess you can take a very large power as well, although you don't need to. These models generally require you to calculate for about 20 to 50 years at most. It's not about the calculation, to be honest. It's about getting the idea, or how should we do this, or how can we solve it. Anyway, so if you can't do that, just let me know. I'll try to show it in a separate Zoom meeting. Okay. Now, let's quickly go back to our math. So, give us 245000. It will give us 292,542.8127. Okay. So this is what the population would look like in 2014 if the growth rate continues to be this. That means if the population keeps increasing in this rate. Okay. Although it's in fraction, So clearly, we want to have a whole number because we are looking for a population which can't be a fraction. It should be a whole number. So as it's more than half, right? We can say that we'll have approximately 293 K. Or if you want to be more precise, you could say 292543, just the next whole number. That means 292543. Okay, that's the closest whole number we have. Or you could say it's about 293,000. Okay, so depending on the options in your multiple choice questions, you could do that. Or even if it's a show your question work, if you reach this stage, that then you're almost done. You just need to round it. Okay. Okay, let's take a break and see if you have any question. Anyone, any question from the discussion we have so far? No question at all? Again, I'm trying to keep an eye on both the devices, but often it's a possibility that I might miss out one or two chats uh, while I'm writing. So if you have any question, you can unmute yourself. Looks all good. Okay, so let's carry on and see uh, what can we do next. So the next thing we want to know is how can we round it, because you can see it's really important to round it in the exact way we want it to be. Okay, so um, for the MyOpenMath, they have a by default tolerance level. That means they have a by default uh, rounding error. If you surpass that, then you might be penalized. So for that, they want you to keep at least 3 digits, okay, uh, after the decimal. Okay, so let's say if you have 293 or 292,542.8127. So definitely it's a population, so it can't be a fraction. That's a that's a different case altogether. You need to round it to the next whole number. But what if it was not population? It was some sorts of other value. Okay, it was, let's say it was consumption of mobile data. Okay, which could be in fractions, because definitely we could have a fraction of a gigabyte um, of consumption of mobile data. Okay, so what if it's not a population? Then we can keep the uh, value after decimal, and the book wants you to have at least 3 digits. So instead, we can write 292,542.813. So that's 3 decimals. And this is more than 5. So I have written 3 in place of 2. Does this make sense? Everyone? It's really important because you can clearly see this if you somehow over round it, I mean, if you round it too much, then the tolerance level might penalize you, and then you might be wondering, hey, I've just gone for the next, or rather closest whole number, but it's still showing me the wrong value. So just make sure, if it's population, then go for the nearest whole number. If it's not, round it like this. It will be really crucial. And it's a computer-based system, so they have a certain tolerance level, as I said. Although I can recheck those, and if I feel you should get partial credits for that, or if you feel that you should get partial credits for problems like this, let me know. I'll try to see if I can do anything else for you. Alrighty, so let's see what we have next. I just hate this spam calls. Sorry for that. My laptop is connected with my phone. So anyway, okay, so one more thing before I go to the next topic. Uh, I guess you can see the participants list from the meeting. So you can see the number of students attending the lecture um, is quite low nowadays. It's about 14 today, and when we started it was close to 30. So it's less than half, to be honest. So what I planned to increase the participants during the lecture is to have a participation, or rather attendance quiz each week. Each week we'll have one attendance quiz from the next week, and it will be done randomly. I'll make an announcement like for that, so no worries. I'll make things clear. So each week we'll have one attendance quiz, but whether it will be on Monday, Wednesday, or Friday, I'll not disclose it. I'll disclose it after we finish that. So for example, I might say on next Wednesday that I have an attendance quiz today, or it could be on Friday in any week. It could be on Monday in the other week. So it will be done randomly. So if you just attend, you'll get 1 point. If you don't attend, you'll get 0.
Will it be like are you gonna put up a poll, or are you gonna send us like an assignment, or?
No, if you just attend it, I can see your name from the participants list. I'll write it down.
Oh, so it's not like an actual like math question. It's just like
No, nothing.
Okay.
So it's not an assignment. If you just attend like the way you have done so far, you'll get 1. But I'll definitely let you know once we start the meeting, not before that. And the reason I'm doing this is just to increase the number of students, nothing else. It's
Right,
not going to be a hard and core grading. Okay. It will just create uh, curiosity amongst students who are kind of uh, trying to avoid the early morning class. I'm not forcing anyone, but it's really important to have a good fair amount of attendance. We have 37 students. And in today's lecture, you're only 14, not 16, because 2 out of those 16 is my account. So only 14 out of those 37 is present today, which is really, really disappointing from the university perspective. I don't mind, but the university wants more and more students to get involved in the lecture. So I'll do that. I'll make an announcement about that as well. So no worries. Um, and it will be done each week. So if you just miss 1 or 2 weeks, it will still be fine. But definitely, I recommend you guys to attend the lectures from now on. Okay, it's just a kind of formality, nothing else. Anyway, let's go back to the next problem. Okay, so you will have one more homework. I'll post it during this weekend, and it will be homework 4. It will be on exponential growth, and definitely you will have at least 3 to 4 days time um, after you finish homework 3. So it will be available from Sunday, hopefully, if I finally post it, and it will have at least 3 4 days of deadline as well. Okay, and before we meet Monday, I want you guys to do try it now 2 and 3. Okay, so that's your pre-class assignment, and your post-class assignment would be homework 3 first of all, which is already posted, and on Sunday you'll have another, which is homework 4. These are really smallish assignments, so no worries. It will not take that much time. Okay, let's quickly see example 8, and hopefully you'll be able to do 1 or 2 more as well. Okay, so example 8. Says, okay, so we need actually the previous example as well. As you can see, it says, looking back at the last example for the sake of comparison, what would be the carbon emissions be in 2050 if emissions grow linearly at the same rate? Okay, so that means they want to compare two things. So that's a very good problem, to be honest. You can actually see, or rather use both the models at the same time, which you have already seen. So we want 7 and 8. Let me rewrite it for you. So the combination of 7 and 8. In 7, we'll try to see the exponential value, and in 8, we'll see the linear value, and then we'll compare it. Okay, so let's first go to 7. Okay, in 7, we have in 1990, the residential energy used in the US was responsible for 962 million metric tons of carbon dioxide. So that's a huge number. Anyway, by the year 2000, so it's in 1990, and in 2000, the number had risen to 1182 million metric tons. Okay, the emissions grow exponentially and continue at the same rate. What will be the emissions grow by 2050? Okay. All right. So, what informations do we have in our hands? So, the first thing I can see is P naught, right? Which is the starting value. So, clearly, it's P naught, right? And we want to generalize these things, right? But what else do we need to generalize or to find the exponential format? We just have P naught. We don't need n because we want to calculate it. So what else do we need? Okay, someone has joined the meeting now. I guess it's too early for the next class. Jokes apart. So what else do we need for finally to finally formulate the model? Anyone? Chat. Okay. what if our Zoom kicks us on and off? Okay, so you can always send me emails or you can rejoin. So that's perfectly fine. And that happens. Yeah, that's the difficulty of technology. Even my internet could uh, kick me out. Anyway, all right. So anyone wants to uh, volunteer this answer? We have P naught. We have one more population in 2000. We're trying to finalize the model. What else do we need? What else we need to calculate? Yeah,
The rate.
the rate, exactly. Is it given? Can you eyeball it from the given informations?
No.
No, very good. Because the rate is not given. We can't see that. If we eyeball the given informations from the book, of course, or even on my screen, you can see R is not given. Okay, so that's a new type of problem. We want to calculate R first. And for that, we have one more population, fortunately. We can use that to calculate R. So how can we use that? Okay, so now the population in 2000 is given. So it's 10 years in between, right? So we can say that P10 is 1 plus R, which we are trying to find. N is 10 and P naught is 962, I believe. Yeah, 962. Does this make sense before I go any further? We're trying to calculate R from this. And of course, P10 is also given, which is 1182. So you can actually see 1182 equals 1 plus R to the 10 times 962. You can see from this equation, we can actually calculate R because everything else is known. But before that, is there anyone who is wondering why this equation has arrived or how can we get to this? Anyone? If you have any doubts, how did you get that, you can ask. Okay, it looks all good, right? Yeah, so we can solve it. Let's quickly do that. So if I change sides for this, 1 plus R to the 10 would be 1182 over 962. I'm just changing sides for this. I mean, I'm dividing both sides by 962. Okay, nothing else. If you have already seen how can we solve equations like this in the problem solving part. If you haven't seen that, no worries. You can always go back to that and see what has happened. Now is the crucial part. We have the power 10 here, and we are trying to isolate this, right? This unknown value. How can we get rid of this 10? Anyone wants to have a go at this? We're trying to isolate R, so somehow or other we need to get rid of this power 10. We can't have this.
Would
Sorry?
you find the square root?
Sorry?
Would you do the square root of it or no?
Okay, a good guess, but not quite, no problems. So if we had a square here, then the square root would have done the trick. But it's not a square, right? It's 10 instead. Let's say we have the nth power. So if you have the nth power, if you want to nullify that, all you need is to upgrade both sides. Of course, whatever you do, you need to do that on both sides because it's an equation. So you need to upgrade that to the power 1 over n, or you'd say the nth root. So you're almost right. If it was a square, the square root would have done the trick. But if we have the nth root, rather nth power, we would need the nth root. That means 1 over n. If we can upgrade this, upgrade both sides of the equation to the nth root, or if you can take the 1 over n power on both sides, it would actually cancel. You can see, you can clearly see this actually cancels each other. And this is what we want. Okay, so before that, let me find the decimal of 1182 over 962, which is 121.2287. I've taken up to 4 decimals. And this 1 plus r would be 12287 to the power 1 over 10. Or this is basically 10th root of this. Either will do, whichever format you would like. This is exactly the same thing. Writing to the power 1 over 10, or writing like this, 10th root rather, is exactly the same thing. So you can write it in any format you like, okay? And in the calculator, once again, you have a button for this. But depending on the model, you might have a different button for this one. So what I want you guys to check, I want you guys to do is to check your calculator and look for signs like this. Okay? Look for signs like this. If you have a button like this will be for the nth root, or on this occasion, the xth root anyway. So you can actually plug in different values here to get your root. Okay? Look for this one, and if you have any problems, let me know with your calculator in the Zoom meeting, and I'll show. Okay? All right. So if we can calculate this, this will give us 0.00208. For R. Okay, so now we have the growth rate, and I guess I had one more zero, sorry. Okay. Now we can finally generalize the model, which is 1 plus this to the n. P naught is 962, we can have it, 962. And now we can calculate what will happen in 2050. We have started in 1990, so 2050 is the time duration of 60 years. So P60 would be this. N is 60, P naught is given. If we can use the calculator, we'll get our result. And I'm not going to waste any more time. I'll see the result from the book. You can cross-check it using your calculator once we finish today. Okay, so that would be the carbon dioxide emission in 2050 if the growth rate looks like or continues to be this. Okay. All right. Growth rate, I mean the emission rate here. Okay. So that's the exponential part. Now let's quickly go to example 8 to see the linear growth of this. Okay. So the linear formation looks like ND plus P naught. And again, we want to calculate D first, right? So P10 is given, which is 1182. It's the population or the carbon emission rate in 2000. So in 10 years, we'll have this. We know that N is 10 and P naught is 962. So clearly, we can calculate D from this. 10D plus 1962. So 10D, if I just change sides for this, it would be 1182 minus 962, which is 20, 220, 220, yeah. And now we're trying to isolate the D, so we'll divide both sides by 10. So it would be 220 rather, divided by 10, which is 22. So we have the value of D. We are almost over time, so just bear with me for one more. Yeah, sure, you can leave if you have a class. I'll take one more minute, because if I leave it here, I'll have to start here, start from here again. Okay, so now P60 would be N is 60, D is 22, and P naught is 962. So I'm just plugging in the values, and this will give us 2282 million of carbon emissions in 2050. Okay, so that's the emission in 2050 using linear growth, and that's emission is for exponential growth. Okay, okay, I'll stop it here. Sorry for the extra 4 minutes. I'll see you next week.